Hi guys, today we will perform a multiple linear regression using a data set that contains the amount of hydrocarbons that escape from a mixture of four different variables. We want to measure the amount of hydrocarbons that are escaping when we uh, when you introduce different types of variables in a petrol mixture. Now let's start with loading the data set. So we're going to do load data set, and we'll name our data set petrol data. And it's going to be a read.csv. It's a CSV file. And it's going to be, our file is named as escaping hydrocarbons.csv, and header is going to be true. And our separator in this case is a semicolon. Let's run that. We have our data set loaded. Let's explore the data set a little bit. So explore data set. So str petrol data. And as you can see that in our petrol data set, we have 5 variables. The first one is tank temperature, second one is petrol temperature, third one is initial tank pressure, fourth one is petrol pressure, and the fifth one is amount of escaping hydrocarbons. So we want to fit a multiple linear regression where we want to see the relationship between the amount of escaping hydrocarbons with the petrol pressure, initial tank pressure, petrol temperature, and tank temperature. So let's try and fit a multiple linear regression model. So we're going to fit a multiple linear regression model using amount escaping hydrocarbons as the response variable, and the rest as the explanatory variables. So let's try and get the names of the data set first. So we're going to control. So we want the names of petrol data. And we can see we got the names: tank temperature, petrol temperature, initial tank pressure, petrol pressure, and amount escaping hydrocarbons. Now let's create the formula that we'll use. So we're going to name it form1, and we're going to do as formula, and we'll paste amount escaping hydrocarbons, scalar braces, and we'll paste the other names in our in the names dataset, that is petrol pressure, tank temperature, petrol temperature, and initial tank pressure. So we'll do n, not n, percent in percent amount percent in percent amount escaping hydrocarbons. Okay, so we'll do that, and then we want to collapse using plus sign. Yep, just gonna bring it down. There you go. So let's run that. And as you can see, our formula looks something like amount escaping hydrocarbons that is estimated by tank temperature, petrol temperature, initial tank pressure, and petrol pressure. Okay, now let's fit the model. So we're going to do ML model, multiple linear regression model. and that's going to be LM. Form 1, we have the formula there. Form 1 and data is going to be control data. Let's run that. Let's get a summary of our model. So now if you look at the summary and look at the estimated values, now let's have a look at the p-values of the estimated values. So if we use a significance level of 5%, that is the alpha equals to 0.05, we can see that the control temperature, that the tank temperature, for the p-value for the tank temperature is 0.75, which is greater than 0.05. So in this case, tank temperature is not significant, is not a very useful explanatory variable. That is also the same case for initial tank pressure. The p-value is 0.14132, so that is greater than 0.05, our significance level. So in this case, we can say that tank temperature, initial tank pressure are not very good explanatory variables in estimating amount of escaping hydrocarbons. So what we're going to do is we're going to get rid of those things, get rid of those two variables, and we'll fit a model without those two variables. So we'll say ML model 2, that's going to be LM. So we want amount escaping hydrocarbons, and it's going to be petrol temperature plus petrol pressure, and our data is going to be petrol data. Let's run that. Let's get a summary of our second model. So now it seems like that petrol temperature and petrol pressure are both significant, as their alpha values are, as their p-values are less than 0.05, that is our significance level. So we're going to stick with this model because this model looks better than the previous model. Now let's run some residual analysis on our model fit. So we're going to do residual diagnostics. Let's calculate the predicted values using our model first. So predicted values, we're going to use a function called predict, and we'll pass in our model, MN model 2. Run that. Now let's plot the actual values of amount escaping hydrocarbons versus the predicted values. Actual values versus predicted values of amount escaping hydrocarbons. So you're going to do a plot there, plot x. We're going to put the actual values in our x-axis and our predicted values in the y-axis. We'll rename the x and the y-axis. This is the actual values. Y lab is going to be the predicted values. CEX is going to be 0.8, and LWD is going to be 5, and we'll add a line to it. Maybe line, or as a line equals to 0 and b equals to 1. We're going to give it a color. It's going to be red, and LWD is going to be 3. Let's run those two lines and see our plot. So as you can see, the plot tells us that our model is a good fit for the data because the predicted values and the actual values are the line in the middle goes like they're not fluctuating too much. There's not a lot of difference between the predicted values and the actual values. Okay. Let's run some more residual diagnostics. We're going to get the residual plots now. So get the residual plots. There are the residual plots. We're going to do par and fro. It's going to be C2 by 2. And plot is going to be ML model 2. So let's run those. And if I expand that, as you can see that a residual analysis, residual plots, all the plots look normal. If you look at the residuals versus fitted model, the residuals don't show any pattern. The normal QQ plot shows that the residual values are normally distributed because it follows a straight line, theoretical normal quantiles. The scale location graph here, plot here, also shows a very horizontal straight line, approximately horizontal straight line. The leverage, we're happy with the leverage because we don't see any values to the bottom left corner, bottom right left corner, or bottom right corner, or the top right corner of the values. So in this case, we would say that our model is a good fit to our data set. That's it for this video. Thank you guys so much for watching my videos. And if you like my channel, please don't forget to like and subscribe. And I will see you guys in the next video.